Okay, so we need micros, we need macronutrients. How much? That's where this section comes in. Okay. This section looks at our dietary reference intakes. Usually I'll refer to them as just DRIs. Okay. DRIs, and this is a fantastic image. DRIs are just an umbrella term. It's just an umbrella term to include everything. EAR, EER, AMDR, RDA, AI, ULs. Of all of these, excuse me, you should probably recognize this one. You probably think of it as the recommended daily allowance. It's the recommended dietary allowance. Okay? This is generally what we think of, okay? Which is good because that's the one that we're probably most concerned about. All of you over here are probably most concerned with this one. Am I getting the proper amount every single day? But all of these have a part to play. Okay? Of these, RDA, AI, AMDR, EER, those are probably the bigger ones. To be honest, those are the ones that, excuse me, goodness, that you are going to interact with and use on a potentially daily basis. Okay. These are going to be things that you're looking at and utilizing when you're doing your diet analysis as well. Okay. All of these things here, all of these DRIs, they are a set of energy intakes, as you can kind of see. Some are energy, okay, and some are nutrients. The vast majority of these are all nutrients, okay. A couple of them are energy related. And we use all of these DRIs to see if we have an adequate diet. If not, we can plan a nutritious plan for you that has all of your recommended dietary allowances, so you don't have any shortcomings. Who uses all these things, or who uses the vast majority of, or who in the heck came up with these things? That would be your Food and Nutrition Board. You all know the Food and Nutrition Board. Okay, these are a group, and they've gone through a couple iterations. Okay, it's at the Institute of Medicine, and they just changed their name actually like a year or two ago. I can't remember, and it's now called the National Academy of Medicine. Okay, so it's the Food and Nutrition Board at the National Academy of Medicine. This is an interesting group. Okay? And you don't need to know this, okay? But this began in the 1800s, 1863 to be exact. I have it written down here. And this was signed in by Abraham Lincoln. So this is something that has been here in some kind of form for a really long period of time. And that's pretty fascinating. It was called the National Academy of Engineering to begin with. And in 1964, they changed their name to Engineering and Technology. And then they changed it to the International or the Institute of Medicine in 1970. And then in 2015, there you go, I wrote it down. 2015, that's when they changed their name to the National Academy of Medicine. I just find some of the history of this nonsense fascinating. But this group here, this FNB, the FNB, they are the individuals that take all of those surveys and look at all of that information to see who's consuming what, how much they're consuming, seeing what individuals have certain diseases or certain conditions. And they are the ones that will change your recommended dietary allowance or your adequate intake. Okay? Those are the two that we probably care about, okay, the most. So they fiddle with these, and they're supposed to change them periodically, I guess they say. Over the last maybe 10 years, there's been some movement with these RDAs, and we're going to need to know RDAs and AIs, not every single one, because honestly, it doesn't matter. The vast majority of nutrients that we consume, we get a hell of enough of because we consume meat. Okay? But those ones that we don't get a lot of, nutrients of concern, those are going to be some RDAs that you're going to need to know about. This Food and Nutrition Board is that governing body that facilitates and moves these things around. Okay, they didn't change it for a really long period of time, and there was some mounting research to suggest certain vitamins and minerals were really lacking in a lot of diets, and people were consuming a hell of a lot more. And that's when they're like, okay, we got to get in here. Really, every 3 years, these should be reevaluated. Every 3 years, nutrition changes pretty dramatically. It's kind of nauseating, to be honest, to keep up with it all. But we do so much research and we collect so much data that's why our concepts of nutrition and how much and what we should consume kind of changes a little bit over the course of 3-5 years. Understanding all of these DRIs is important. I don't know if I'm going to ask it as a short answer question, to be honest. I may ask it as that. I've done it in the past. Sometimes I've done it that way. Sometimes I've done it as a multiple choice. Sometimes I've done it as matching. But it would either be a multiple choice or some kind of essay type question and fold it in there somehow. But that's probably how I would ask. So here's our first one here, the EAR. The estimated average requirement. I have underlined up at the top there what it is. The EAR, the estimated average requirement, is the amount of a nutrient where it meets 50%, meets the needs of 50% of healthy people, okay, in a particular life stage or sex group. So, 20-year-old pregnant women, 30-year-old men, okay, 10-year-old girls, 8-year-old boys, that type of thing. All right. But the biggest thing here, boys and girls, is it's meeting the need for 50%. Okay. 50%, that seems really low. It is. We don't utilize this. The FNB does. Okay. An EAR is established so we know what we can make for an RDA. We know what level we can go to make it safe for the vast majority of individuals in a population. That's the, excuse me, that is the significance of the EAR. Okay, we take, excuse me, excuse me, goodness. We take some kind of biological marker, heart rate, skin temperature, stuff like that. Some kind of physiological thing that we can monitor. Okay. And they see if the substance in the body reflects the proper function, and we measure that. Blood test, urinalysis. Okay. And so that's how they figure out this meets the needs for 50% through doing all that scientific research. But what is it? There at the top. What's it for? There at the bottom. Okay? Those are two things that I probably will ask more than anything. And here you can see 50%. Yep, it's 50%. There it is. Okay, meets the needs for 50%. Once we got this, now we can figure out what the recommended dietary allowance is. And when I say it meets the needs for the vast majority of individuals, there you go. 98% is the vast majority of individuals. Okay. You may be somebody who is normally healthy and you can consume a little bit more. That's okay. 2% of the population, that's okay. You can figure it out. Right? These are our daily intakes. RDAs, this is what we utilize every day. When you look at that bottle, I should have brought my bottle. When you look at that bottle on your vitamin, right, but it says it has 35% of your RDA, this is what they're talking about, the recommended daily intake, the recommended dietary allowance. Okay. Again, it meets the needs for the vast majority of individuals, healthy individuals in a particular group. Okay. And you can see from this fabulous picture here that 98%, hell of a lot higher. So EAR, we don't really utilize. It's more of the scientist. Okay. RDA we do. The other one that we utilize are AIs, adequate intakes. An adequate, I am sorry, guys. I have something in my nose. An adequate intake is really an assumption. It looks at the average daily intake of a population, and it comes up with a recommended amount. Why would an adequate intake be established? That doesn't sound very scientific. Well, it's not. I mean, they're just looking at averages. But generally, these are established AIs when there is not a whole heck of a lot of scientific research done, or really if there is no known toxicity, or if there's no known deficiency syndrome associated with it, that's when they usually establish an adequate intake, okay? Because we don't need to, right? If you get, on average, most people consume this daily. If you get on average of this, then you're generally sufficient. There's no disease process associated with it. That's what it is, okay? It is just an estimate, though, okay? It is just an estimate. There's not a whole lot of scientific evidence, not a lot of anecdotal information to go and look at scientific research or to justify paying for scientific research, and sometimes to suggest that there's any disease process associated with it. Okay? So that's what these are. All right. On the next slide here, I have a list. You don't need to know. Okay. But there are, fiber. Yeah. We have an adequate intake. America gets generally pretty low amounts of fiber. So that's why it is kind of a nutrient of concern for Americans, just because generally we don't get enough of. But if you get a general ballpark around it, we're fine. You get way too much, then bad things, okay? But that's on the extreme end of the spectrum. If you don't get enough, there are some things that can potentially happen, but it's not for every individual. And that's what helps to establish this adequate intake, rather an RDA. Same thing for water. It's like, anywhere between, depending on if you're a man or a woman, 11, 12, 15, 16 cups of water. Okay? Some people can be perfectly fine with 11. Some need 16. It just gives a nice little range. Right? We'll talk about some of these, like fiber, obviously, water, sodium. These are going to be adequate intakes that are going to be pretty important to know. Right? But some of these other ones we're not going to worry about. Okay, fluoride, chromium. We're not going to be worried about those adequate intakes. For one, you need really, really, really small amounts. And two, it's in a buttload of everything. So you come in contact with fluoride daily, unfortunately. And we'll talk about that later. RDA, AI, those two you're using. Another one you would maybe use is upper level. Sometimes it's called upper level. Sometimes it's referred to as tolerable upper intake level. Man, whatever. They both mean the same dang thing, right? This is taking a real high amount, okay? Sometimes these are established to let us know what the toxicity risk is. The only reason why you would be concerned with an upper level limit or tolerable upper intake level is if you supplement, okay? Is if you supplement. Because that's where you're going to see yourself or somebody else reach these upper level limits, all right? These are generally never met with real food, with natural sources, okay? It's only reached when you do supplementation. And when you do your diet analysis, if you don't have a need for certain need for vitamins, like if you don't have a condition, a health condition, then don't take them during this time that you're doing your diet analysis, just for grins and giggles, just so you can see if you are truly, truly, truly getting enough vitamins and minerals from your diet. Okay. Now, I'll say this now, but if you do have some kind of condition, please take your medication. Okay. I've had some instances where some students have stopped taking like certain things and meds and whatnot to see. Good Lord, please don't do that. I don't want you dying on me. Okay? I don't want you dying on me. All right. So, but if you don't have some kind of diagnosed condition, stop taking your vitamins. All right. And see if you do kind of meet the RDAs for all of these things. All right. So if you're somebody who supplements, like me, I do. Okay. I take some multitude of various different little things, a multivitamin, multimineral for one. I probably exceed my RDAs for a lot of things. And, I'm not concerned with UL though. That's because my activity level is pretty high generally. I sweat, I do a lot of stuff. So, I lose a lot of that stuff that I intake, which is why I supplement or I exercise really hard. So I have a greater need. So I feel like I need those extra supplements, that extra multivitamin, multimineral to counteract for any deficiencies that may happen because of my excess activity level. So if that's you, you may not be worried about upper level intake. Let's say you're not a healthy individual. Okay, you have high blood pressure or something along those lines. Now it may be something that you want to try to pay attention to. Okay, because some of those upper level intakes of some of those minerals can affect blood pressure in that regard, water balance, which would affect blood pressure in that regard. So why do I keep saying RDAs and AIs are the vast majority that you interact with? Because that's generally this Goldilocks zone. Okay. RDA and AI generally means if you're getting that amount, you are consuming the proper amount of vitamins and minerals and everything else during your day. Okay. When you get to that upper level limit, now you're kind of pushing it. Okay. You may need it, but you may not need it. And that could be high intake, and that could be some toxicity issues. We'll talk about that when we look at vitamins and minerals, because that's where you really start to see them a heck of a lot. We'll talk about them too with the macros when you take too much. But really diseases, we're going to talk about a heck of a lot more with vitamins and minerals. But you can see if you get lower, below that RDA, below that adequate intake, you can see you can increase your risk for deficiencies, risk for diseases as well. It's not a toxicity issue like it is past upper level limit, but it's now a deficiency disease or a deficiency syndrome. Okay. So you want to know those RDAs and AIs. That's generally what we interact with on the daily. We have all of those that we just looked at, EAR, RDA, AI, UL, all of those looked at nutrients. Okay. All of those 4 looked at nutrients. These 2 here, EER, not to be confused with EAR, the estimated energy requirement, and AMDR, acceptable macronutrient distribution range. These 2 are involved with energy. And you can see it's in bold. Why is my pen not working? There it is. Okay, there it is. Okay. Average daily energy intake. Okay. Again, healthy individual, maintaining your weight, his or her weight. Okay. Estimated energy requirement takes into account, as you can kind of see, sex is still there. Males and females have different energy requirements, usually because of different amounts of lean muscle. Life stage is important. So again, infants, toddlers, school age, adolescent, adult, old person, pregnant, not pregnant. So life stage effects, but height, weight, physical activity level. If you're somebody who's really active, you can consume more. If you don't exercise, if you don't have a lot of physical activity, you can't consume as much. It will be fascinating when you start to do your diet analysis. You'll look at how much you're consuming. You're gonna be like, man, I am not losing this weight and I'm only eating like 800 dang calories. What in the heck is going on? That's the problem. That is the problem a lot of times. Just because you're consuming really, really, really low amounts of food, of energy, calories, right? So if you're not consuming calories, your body doesn't know that you're wanting to lose weight, right? Your body knows that all of a sudden, man, there is not enough energy coming in. So we must be in a famine. We must not have access to food. So you know what your body does? Releases various different hormones and chemicals to get you to conserve energy, holding on to that fat. It doesn't understand that you could trip over food and get more food very, very easily. And sometimes the foods that you're choosing can affect that as well. That's all the fun stuff of nutrition. We'll talk about that a little bit later. But how much you're consuming, all of that goes into it. So, if somebody's, 6'3", they're going to be able to consume more because they're taller, more mass to them. They're taller than you at 5'2". And they're going to require more. It takes more to maintain that. It doesn't take as much to maintain 5'2". I'm sorry. Okay, same thing for weight. Okay? Greater weight, greater mass, greater things to maintain. So, and we'll see this especially in children. Okay, there are height, weight requirements, and there are estimated energy requirements for children. Especially within the teens, with varying different body weights and various different activity levels. They can go anywhere from like 1,000 to 3,000 calories. It's crazy, but kids are furnaces, so they can generally consume a lot of stuff as long as they're have some activity to them. So estimated energy requirements. Energy intake meets the needs to maintain a healthy body weight. AMDR is one that, if you count calories or if you count carbs, this is probably one that you've interacted with. Okay, the acceptable macronutrient distribution range, or AMDRs. Okay, you should know those percentages right there, because they're going to get asked. They'll get asked in this unit, they'll get asked in the next unit, so just start memorizing them now. For carbs, 45% to 65% of your EER, of your calorie intake, of your estimated energy requirement, your calories you take in, 45% to 65% should be carbohydrates. 20% to 35% should be fats, and 10 to 35% should be proteins. If you're somebody who carb cycles, then you go on that higher end of that spectrum, 65%. And then on days where you go low carb, you'll bottom it out and you'll go 40, 45%. On those days that you go low carb, you'll increase your fat intake. So if you go on the lower end of the spectrum for carbs, you're going to go on the higher end of the spectrum for fat. And that's just generally what you do if you carb cycle. Protein, you generally like to keep that the same. If you equate for protein being the same throughout the entire time and just fiddle-faddle with your carbs and your fats, that's generally where you're going to see a loss of body fat, an increase in lean muscle mass, increases your basal metabolic rate, you burn more calories, yada, 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 yada. All right. But we should know these, because if we consume way too much carbs, which the typical American diet generally does, this is going to increase our risk for disease. Okay? Type 2 diabetes. If we consume on the high end of fats, or a heck of a lot more fats than we're supposed to, risk of health conditions, arteriosclerosis, atherosclerosis, heart disease, heart attacks, angina, strokes, okay? Health complications. There's not really a whole heck of a lot of health complications associated with proteins. Some people will talk about if you excessively consume protein, that can have an effect on kidneys. There's some new research out to suggest that that's not necessarily the case. Um, that actually, if you are in a disease state, you would need more protein to help with the wear and tear to build up those structures. But we'll talk about that a little bit later. Okay? That's a rabbit hole that's fun to kind of get into. But those are your AMDRs. All right. So if you know your EER, how much calories you need to consume to maintain your healthy weight, then you go your AMDRs and be like, okay, I need 60% carbs and 30% this and then 10% protein. Okay. And there you go. And now you can make a nice, healthy, fantastic, varied diet. Why do we need to know these? Well, you need to know if you're getting enough. You can use this to see if your daily food intake is high quality, high nutritional quality. If it's not, then you can plan to incorporate certain foods to get those nutrients that you're lacking. Pharmaceutical companies also utilize these as well when they create different formulas. You see this in infant formula. You see this, there's a huge market, and hopefully we'll get to watch that video. I'll be put it up anyway towards the end here, so you can watch it. But pharmaceutical companies, medical or not medical, but food manufacturing companies, they create a lot of food. Most food, a lot of food, is man-made and manipulated. A lot of it. And I don't believe there's any natural food that's really high in carbohydrates and fat. But we've created a lot of that type of food. And that triggers various different chemicals in the brain that drives us to find that type of food. And that's a contributing factor to this obesogenic environment that we have here. So there's a lot of good for this, but there's also this potential kind of devil that sits on your shoulder there with the creation of a lot of different manufactured foods, functional foods, right? I mean, like adding omega-3s to peanut butter. Okay, that's not devil incarnate at all. Okay? But there are a lot of things that our bodies just can't utilize as effectively. It doesn't fill us up. So I'm still hungry, so I'm going to eat more. And now you can see we can have this downward spiral of poor health manifest. There's a little link there. This is a link for macronutrient, micronutrient recommendations. So if you're somebody who wants to dive down the rabbit hole and do a little looking around and kind of seeing what it is for your specific, you're a 22-year-old sitting there in your dorm room, whatever, what are the recommendations for you? You can click on that, and that takes you to the Department of Ag's website, and it has a DRI tool, and you can kind of see everything for you if you're curious.